of quadratic equations. So the good news is, like I was saying yesterday, like there's not a whole bunch of like super new stuff, like conceptually. It's just a matter of like putting this stuff together in a different way. Here, Ashley. So the process that we use for solving these problems is exactly the same as it was for solving application problems that dealt with linear equations. The only difference is that when we write our equation in step 2, it's going to end up being a quadratic equation that we have to solve rather than a linear equation. So remember, we did all those problems that were like the perimeter of a rectangle is this and this and this, and we had to list our unknowns and assign one of them a variable. That was step 1, and then translate the equation into, or the problem into an equation using our variable, solve the equation, and then answer in a sentence. So those steps are exactly the same. The only difference here is that the equations that we write will end up being quadratic equations, like the ones we solved yesterday, rather than linear equations like they were the first time we did this. So let's just do a bunch of examples, and then, I mean, like I said, we don't have a whole bunch of stuff to do today, so maybe we can enjoy the sunshine a little bit faster. So the length of a rectangular hallway is 3 feet more than twice its width. So to start with, this is exactly like one of the problems that we've already done, right? They told us information about the perimeter in the past. If we keep reading, we see that now they're telling us information about the area, which means instead of adding all the sides up to write our equation for perimeter, we're going to multiply the length and the width to write an equation for area. So we're going to start again with length, width, so just listing our unknowns. And one thing that we did add into this as we kept going through the material in chapter 3 and 7 is that we can solve these using systems. So it's sort of up to you, like when you have more than one variable, if you want to use a system of equations or if you want to use a single equation. The key is that the number of variables you choose is the number of equations you have to write. So if I were to be like, this is x and y, then I would have to come up with 2 equations. In this case, I'm not going to do that. Like, there's nothing wrong with you doing it, and it's like totally up to you. But in this case, they tell me what the length is in terms of the width fairly easily. Like, it's not a complex relationship. So it's just as easy for me to say that the width is x and the length is 2x plus 3 as it would for me to be like, oh, the length is y, and then write the equation y equals 2x plus 3 as one of my equations, right? So I usually reserve using systems of equations for when like the relationship between the variables isn't like super duper clear. Like when you have something like one team shot 5 3-pointers and 6 2-pointers for a total of this many points, and the other team shot this many 2-pointers and this many 3-pointers for a total of this many points. Like, how many of each did they do? Like, where there's not like a super clear relationship between like how many 2-pointers and how many 3-pointers there are, right? But you do have 2 pieces of information that'll give you 2 equations so you can solve. So in this case, it's like really clearly stated like how you get the length from the width. And so I find it easier just to write the length as 2x plus 3 than to write it as y and then have to come up with a second equation. So next we'll write an equation. Remember that area is length times width. So I have x times 2x plus 3. I know I wrote it as width times length, but I like it. I think it looks better this way than to have the x on the other side. And that is equal to 44 square feet. And so problems like this one are the reason that yesterday, like I gave you so many different variations of what a quadratic equation could look like when you get it. Because it's not always going to necessarily look like a quadratic equation. Like it's not necessarily going to have an x squared in it or be really like easy to factor right off the bat. So remember, our first step is to get a 0 on one side. So we're going to subtract 44 from both sides. Is this factored?
No.
It is not factored, right? Because we've got that subtraction outside of parentheses. And so if it's not factored, then our first goal is to simplify it, and then our second is to factor it. So that sometimes means that you have to like distribute before you get to factor. So I'm going to distribute that x, which gives me 2x squared plus 3x minus 44 equals 0. And then make sure you combine any like terms that you can in this step before you try to factor. In this case, we don't have any like terms to combine, but you always want to double check. So our AC is negative 88. Our B is 3. If my AC is negative, what does that tell me about my two numbers? One is positive and one is negative. Good. I was just grading some worksheets that you guys turned in on Monday, and on the test too, I noticed that's something that, again, as you guys are starting to get faster at factoring, you're skipping over some things every once in a while. And one of the things that we're starting to skip over a bit is writing like what our signs are going to be, which can often cause some sign errors, because sometimes you try to force like the numbers to add to B by changing the signs around, but then it messes up the fact that they multiply to a positive or a negative. So let's see, 88. 1 and 88.
8 or 11.
Thank you. That was just not coming to me. So 11 and negative 8. So 2x squared plus 11x minus 8x minus 44 equals 0. We can factor out an x. And we can factor out a 4. Another thing that I wanted to point out, again, just like little things I noticed as I'm like grading stuff, is that the number that we factor out here isn't always necessarily going to be that number, right? Like it's just whatever that 8 and 44 have in common. So in this case, they have a 4 in common, which means that like this is not necessarily always going to be an x, right? If I take a 4 out there, I end up with a 2x. So there's certain things that happen so often, sometimes we get in the habit of doing them, but they're not true for every single problem. So we just have to be careful that we're not getting stuck in patterns that don't always apply. So equals 11, and that gives me 2x plus, I have no idea. I was looking at the 11 above it, thank you. Plus 11 times x minus 4 equals 0. And so then we'll set each factor equal to 0. So negative 11 over 2 and positive 4. So what did I just find out about my rectangle? Because if you have 2x plus 11, you have to subtract 11 from both sides. So what did I just find out? I see furrowed brows. Yes. What is the width?
4.
Yes. Because the width is not negative 11 halves, right? I've never seen a negative number on a ruler. I don't know about you guys. But like length, measurements are always positive. And so we write these models, like we write these equations to accurately represent situations, but sometimes the equations end up giving us more than we need, right? So like we have two solutions, but this solution isn't valid because it doesn't make sense. What's up?
You get 2x plus 11 equals 0 from there.
So when we have the product of two factors equal to 0, then one of the factors has to be 0. So if this was equal to 0, then multiplying it by x minus 4 would give me 0. And if this was equal to 0, multiplying it by 2x plus 11 would give me 0. So either one of those factors could be 0. So we threw out the solution that doesn't make sense and said, okay, our width is 4. When they ask for dimensions, what does that mean?
Length and width.
Yeah, the dimensions of a rectangle are length and width. So that's what they mean. Like often, like when somebody asks for the dimensions of like this piece of paper, we say it's like 8.5 by 11, right? So that's the length and width. You don't even have to specify which is the length and which is the width. In this case,
for the final thing,
yes.
couldn't we just say 4x equals 11, or 4x equals 44, and find it that way also?
4x. Oh, sure. Yeah.
Okay.
Or wait a minute.
Because if we know there's length
Well-
times width, and we know what the width is,
Yes. I think what you're saying is like you can divide the area by the width and get the length. You wouldn't actually write 4x equals 44 because x is 4, right? X isn't the length. So like if you wrote this, what you're solving for is the length, which isn't actually x. You see what I mean? Like you already solved for x. X is 4.
okay.
So like you can't use x again to represent something different. But your thought process is correct. Like you can say, what do I multiply 4 by to get 44 to get the other dimension?
So will this
You could
solve-
even make up a variable like y or a or yes.
Will this solve without doing that? If you just took the, did you just distribute property with the x, 2x plus 3, and then did your move the 44, or get x on one side?
So when we have equations that are not linear, so are not degree 1, there's no way to get x on one side because there's two. So when we normally write an equation or solve an equation, we have like 5x plus 7 equals 9x plus 3. And it's okay that there's two terms containing x because when I subtract, I can combine these like terms. But when I have instead like this,
You can't get rid of
then when I subtract, I can't like make that into a single term containing x. And so there's no way to reduce it down to a situation where I just have one x, which is why we factor so we can break it up into factors that just have one x. So really every single equation that we solve, it'll be a matter of finding a way to break it up into one or more linear equations. So like when we solve rational equations, which are equations that contain fractions, we'll clear fractions so that it is then a linear or quadratic equation. When we have radicals, we'll undo the radicals so we then have a linear or quadratic equation. So everything is a matter of just breaking it down so that we can solve a linear equation by isolating x. And there's just different ways to do that depending on the type of equation that we're dealing with. Other questions on this one? Okay. So this next one is an example of what we refer to as modeling, which is people ask all the time, like, how is like math used in the real world? Because it seems like we don't use it that much, but really it's everywhere around us using what we call modeling, which is taking past information and then building an equation to predict things in the future. It's what they use the census for, like how they can tell us how many people are going to, like what the population of the United States is going to be in like 50 years. They use a model. So they look at how it's grown over history, and then they come up with a mathematical model that fits that data, and then they can use that to make predictions. They do the same thing, like business owners do the same thing to like predict how many people they need on the floor during different times of the day, things like that. So like it's used everywhere. People just examine past behavior and then come up with a mathematical way of predicting future behavior. So we see this a ton, and it comes up a lot in Math 121 because it's really focused on modeling, but you'll see models in business a lot, so if you're a business major, and of course in the sciences they use models all over the place. So the deal with answering questions that have a model given is they give you an equation. It has two variables in it, so it has two unknowns in it, which means that if they ask you a question, they either have to give you, in this case, the height of the ball, and you're finding the time that it reaches that height, or they have to give you how long the ball has been in the air, and then you're finding the height. So, and then you're just plugging in for one of the variables and solving for the other. So like the simplest question we can ask, which I didn't put on your piece of paper, is something like, how high will the ball be after 1 second? So in a question like this, so we identify what our variables represent. H is our height, and then T is like the time in the air. So in this case, they're asking how high, so they're asking what is H. And then they're giving us the amount of time in the air, so they're telling us that T is equal to 1. So then I take my model is exactly as it's given, and I'm just replacing my T with the T value they gave me. So H equals negative 16T squared plus 32T plus 240. And I'm just putting a 1 in for all the T's. Which gives me 256. So after 1 second, the ball is 256 feet in the air. So that's sort of the simple example because we didn't have to do much to solve. We just had to, once we plugged the 1 in, we just had to do the calculation, right? Like we could just eventually plug that into our calculator. You guys cool with that?
But it's kind of simple because 1 doesn't change any of the values.
Exactly, yeah. It would be a little bit more work if I gave you a number other than 1, but you could still do it. It's just arithmetic, great. So then in these examples, we see the word when in the question, which means they're asking for a time. So that means they're asking, like, what is T? And if they want to know what the time is, that means they have to give us H. So here's H. Come on. So this tells us H is 240. And notice in these problems, I didn't list my unknowns and give them a variable because that was already done for me in the problem. They already told me in the problem what h represents and what t represents. So I don't have to say it again, although sometimes, especially when you get into problems where you have multiple equations and multiple variables, sometimes it's nice to make a list of what each one represents just so that you don't have to keep going back to the problem. So you could, if you wanted to, just to give yourself a quick reference point, you could be like, height is h and time is t. But that's not something I'm going to grade. Like, it's not required for problems like this because they tell you in the problem what the variables represent. So those are already defined for you. So we're going to take our model again exactly as it's written. You guys ever listen to one of these tours? You learned so many cool things. Did you know that you could get married in the chapel and that Champ will officiate your wedding?
Well, that'll last for a long time, won't it?
Classy. She tells him that every time she walks by because, like, I'm like my office is right there. It's hilarious. People get really excited.
Has anyone ever had Jam officiate their wedding?
I mean,
To your knowledge?
not to my knowledge, but
Sure they have.
I'm sure somebody is like, and like in the wedding
It sounds like
pictures.
something my
And,
sister would do.
I mean, it could be fun. Okay.
No.
So I am now going to replace h with 240. So 240 equals negative 16t squared plus 32t plus 240. And so this is a quadratic equation, right? I have an exponent on the variable, which means my first step is to get a 0 on one side. So I'm going to subtract 240 from both sides, which gives me negative 16t squared plus 32t equals 0. I kind of flip-flop the sides there just because
Thank you.
we like the 0 on the right. It looks nicer. So now I'm going to factor. Remember that we want descending order and we want the first term to be positive. And so when I factor out my GCF here, I'm going to factor out a negative 16t so that I can get rid of that negative on that first term. So I'm taking out negative 16t, which gives me t here and then minus 2 here. And so we'll set both factors equal to 0. And we get t equals 0 and t equals 2. What does that mean? What did I just find out?
So it'll be 2 feet above sea level. Oh, no, 2 seconds, it'll be 240 feet.
What's the 0 mean? You sure?
No.
What does t equals 0 mean in this case?
The height it is at 0 seconds.
Yeah, so like when you throw it, right? So the problem says that the child is throwing a ball off a cliff. That doesn't sound like a safe situation. Let me read it. And so like, here's your ocean, right? This is like a height of 0. That's way too small. Of 0. And then there's a cliff. And this is 240 feet high. And so like the kid is like standing on the cliff and throws the ball up in the air, and then it like falls down into the water.
Better go get that ball.
When they just drop it though, because if you threw it up, then you can account for the time and the curve. Or at what
Well, that's
point-
what this equation does, is it accounts for the fact that
Oh,
it was
it does
thrown
account
up
for
in the air, yeah. If you're at all interested in physics, this term in the equation, that negative 16 has to do with the force of gravity. So the acceleration due to gravity is negative 32 feet per second squared. And because of how you take derivatives, that coefficient is half of that. And then this one, that coefficient represents the initial velocity of the ball, so the speed at which he threw it up. If that was 0, that would be dropping it.
So
And-
then that 0 is just going to equal 240 then?
Well,
Or it's
so
going to represent 240 because that's
a
what...
time of 0 corresponds to a height of 240.
So it's the beginning, and then the.
Yeah. So this is our height of 240. We're saying that we started right here when we threw the ball, and then after 2 seconds, the ball has hit its maximum height and is now passing the kid's hand again.
Oh, so it's not at what point it hits the water, it's at the point
Where it's at a height of 240.
240.
So on these problems, one thing to keep in mind is that if you solve for time, you can get 2 answers that are perfectly valid. Like if I gave you a height of whatever this is, the ball is going to reach that height once on the way up and once on the way down. So both of those would be valid solutions, like whatever t values you got, because it hits that height at 2 different times. And then, I mean, everything down here, there's only going to be one valid answer. You'll get a negative, which extends this back in time, basically, which won't make sense. So you'll just have one positive answer. But this is one of the few applications where you can get 2 positive answers that both make sense in terms of the problem and are both valid answers. So you want to be careful of that. So then the next thing we're going to do is find when the ball will hit the water. So how long it takes after he throws it up in the air for it to actually hit the water. So how long he has to run down to retrieve his ball before it floats away. So they're asking for t here, just like before. So what is t? And if they're asking me what t is, that means that they have to give me h. What is h in this situation?
So just one more question
Yes.
on A.
Sure.
So when we're handwriting out the
Oh, I'm
answer,
sorry.
So we would include 0 because that is technically correct, and 2.
At a height of 240 feet. And reaches it again. After 2 seconds. So that's how I would say it. I mean, if you said the ball is at a height of 240 feet at 0 and 2 seconds, I would accept that. Sorry, I got really into my picture. I forgot to write a sentence. Thank you.
It's a really nice picture, though.
Thanks.
Yeah,
I tried.
I want to frame it.
I'm not known for my artistic abilities. Come on, there's
Freak out, you can put like a little fence.
You need stick figures
So
right
no
there.
kid's safe.
You need a little stick figure throwing a ball.
with his water wings on.
So H is going to be, you're going to substitute the T, aren't you, for 0 or 2 in the formula?
So I don't know what t is. I can't use 0 or 2 because t equals 0 and t equals 2 will give me a height of 240, which isn't where the water is.
Don't you have to subtract that out of the throw, right? Because, is this saying that he's, no, because it's saying if he arcs the ball over.
So one of the things with models is that sometimes we tend to want to kind of make things up on our own because of what we know about the real world. But the thing about models is they give you every piece of information that you need. You don't have to worry about anything that's going on. Every single time you know a height, you can use the equation to find a time. and every time you know a time, you can use the equation to find a height. Like, you don't have to, like, to deduce anything from it, because all the information about how that ball behaves is built into the model. So all we need is a height. So when you hit the water, what is the height? 0, yes. So there are a lot of these questions that we call them projectile problems, that have to do with things being thrown up in the air. And they often ask when it hits the ground or when it hits whatever it lands on. That's always means a height of 0. So when it asks when does it hit the ground, it's always asking when is the height 0. So here they're giving us h equals 0. So we are going to replace the h with 0 and solve for t. This is a different equation, though, than the other one, because the other one, in order to get a 0, we subtracted that 240, right? Here, we're ready to factor immediately. I'm going to factor a negative 16 out first. Can I do that? No.
It's going to be 4. It's going to be 4.
I can do that.
Because it's a common factor.
Yes, it is going to be 4. So 0, I'm going to switch sides.
Oh, thank you.
So negative 16 times t squared plus, nope, minus 2t, 240 divided by 8 is 30, 15, minus 15 equals 0. So then AC equals negative 15. Oh, no, it's not going to be 4. It's going to be 5. And B equals negative 2. So my numbers are negative 5 and 3. Are you guys ready for a factoring shortcut that will blow your mind? Again, you have to know when you can use this, because if you use it in the wrong place, you'll mess up the whole factoring thing. When your first term has a coefficient of 1, so there is no number there in front of your first term, then we know that, like, that has to be t and t. These numbers just give you those constants. So you don't actually have to write your, like, split up your middle term and factor by grouping. You can just throw those numbers, like, right into your factors. Again, that only works when the first term is like x squared, where it's not like 5x squared or 2x squared or something like that.
So then you can't do anything further than that.
Right, then you're done. So we'll set each of those factors equal to 0. Oops. So we have t equals 5 and t equals negative 3. So all that negative number means is that if you were to follow, like if somebody had been down here and had thrown the ball up in the air, like on that same exact trajectory, it would have taken 3 seconds to get to like the top of the cliff, to where the boy was. So it's sort of like going back in time. But in this case, like, we don't go back in time. So the only one that makes sense is that 5. So
the ball will hit the water in 5 seconds.
uh-huh. So you will encounter a lot of problems in this class and in your next class where They just give you a model and then they start asking questions about it. Regardless of what the situation happens to be, the problems are all essentially the same. Like they have to give you one of the variables and then they're asking for the other one. So you just have to identify which one of the variables they are giving you a value for and then solve for the other one. It's kind of nice because we don't have to come up with an equation, right? Any other questions on this one? Okay, consecutive integers. I want you guys to try this one all by yourself. I will give you one hint, which is that product means what operation?
Addition. No, multiplication.
Multiplication. So think back, way back, like, because they don't, when they say how wide is the frame, they don't mean this width. Like they don't mean how wide is like that whole thing. They're referring to like the actual width of the frame itself, like from here to here. So like the border, the actual frame, not the entire picture. So we're gonna call that X. And for step one, where you identify your unknowns and state what they or assign them a variable, for problems like this, it's perfectly acceptable for you to use just the picture to identify what X is, as long as you clearly label it on your picture. So all the way around, this distance is X.
Does it matter where you put the 8 where the 10 is, and the 10, I mean, it'd be
Sure,
weird.
doesn't matter.
Doesn't matter.
So let's start with this distance right here. How could we express that? So remember, look only horizontally. What do we know going left and right?
X,
2x plus 8.
Uh-huh. Yeah, so we know that from here to here, it's 8. And then each of these is X, right? Can't fit that in there. 8. So that entire distance is going to be 2x plus 8. And then what about the height of that whole thing?
2x plus 10.
Yep. So we didn't actually have to find the area of a shaded region here, but it's that same kind of idea where we're using the information from that picture to get the lengths that we need, so that we can write the area of the whole thing. So 2x plus 10 times 2x plus 8 equals 143. So to get a 0 on one side, we're going to subtract 143. And then in order to factor that, we're going to have to distribute and combine like terms. So we've got 4x squared plus 16x plus 12x, 20x, plus 80 minus 143 equals 0. So 4x squared plus 32x minus 63 equals 0.
36.
Yeah.
20 and 16.
Wow, I really am stuck on that being a 12, aren't I? Thank you. Okay. So now our AC is 240 plus 12 is 252. So negative 252. And B is, I'll put it over here. I'm running out of room.
36.
B is 36. So I need a positive and a negative. And I would probably use prime factorization for this one. So the prime factorization of 4 is 2 times 2. The prime factorization of 63 is 7 times 3 times 3. So that's the prime factorization of 252. Right, because here's 4 and here's 63. When you multiply those together, you get 252.
That's pretty quick. Been doing math a while.
So, and on problems like this, you can kind of like use a little bit of common sense. Like if like 1 and 252 isn't going to work because they're too far apart, right? To like add to, because one of these numbers is negative, like they're way too far apart to get to 36. 2 and whatever this is, also probably too far apart, right? That's like 126. And then I need more room.
7, 9, no. Oh, 9 and 4.
9 and 4. Oh, you're thinking of multiplication.
Yeah.
We want addition to
Yeah,
make
no,
36.
Something like
So 4, well, 4 and 63, we already know that isn't going to add to 36. Is 5 a factor? What about 6? So there's 6. Yep. And we found it. So some of these can seem a little overwhelming when the numbers are big, but often if we just kind of like start doing it, it doesn't like take as long as we were afraid it might. We often spend more time worrying about how difficult it looks than actually doing it. Or not how difficult it looks, but how tedious it looks. So we're going to use negative 6 and positive 42. We cannot use a shortcut here. So that shortcut that I showed you is not applicable here because of this 4. Yeah. So we just do it the long way. So 4x squared minus 6x plus 12x, 42x minus 63 equals 0. So 2x minus 3 plus 14, no. $21 times 2x minus 3 equals 0. So we get 2x minus 3 times 2x plus 21 equals 0. And then we'll set each of our factors equal to 0. So 2x minus 3 equals 0. And 2x plus 21 equals 0. We can throw that guy out because we're not going to have, the width of our picture frame isn't going to be negative. And so our answer is going to be 3/2. Now, since we're writing this in an English sentence, we'll write that as 1.5 inches, right? Remember, the reason that improper fractions are called improper is because they're improper English. So nobody goes to the store and says, I'm looking for a picture frame that is 3/2 inches wide, right? We would say 1.5 inches or 1.5 inches. So the frame
just like you would look for pregnant.
is 1.5 inches wide. You'd say 1.5 here too, it would be fine. You always want to keep in mind what you're actually looking for, right? Was the width of that frame, which is what we identified as being X. They could have asked for the dimensions of the whole frame, in which case we'd have to plug that back into our 2x plus 8 and our 2x plus 10. But they just asked like how wide that border was. Any other questions on this one? We're almost done.
It's not, it seems more simplified. if
It's
you write the
really
picture.
easy to follow along with you when we do it here. But when I'm by myself, things get really crazy.
So that's why you want to that's why I give you like these steps, right? So that like you can break it up into smaller pieces. So like on this one, the first thing you want to do is just draw a picture. And like when you're drawing the picture, just focus on drawing the picture. Like I find that a lot of people, myself included, I do this with like when I encounter a difficult problem too. It's like I think of something and then I'm like, oh wait, but then how am I gonna like, and I start thinking of problems I'm gonna run into like before I actually run into them. And then I just like disregard the idea I had. So like, you want to just start somewhere and like follow it through. So like you want to start with a picture, just focus on that. And then the reason that I knew to draw the picture the way I drew it, so like I labeled what they told me, the 8 and the 10. And then the reason that I knew that I needed that 2x plus 8 and 2x plus 10 is because they told me the area of the whole thing. So like when I write an equation, I look for the information they give me, and then I'm like, okay, how would I calculate that? So how would I calculate the area of that whole thing, including the picture? Well, I would multiply the length of the whole thing by the width of the whole thing, which means I need some ways to express each of those things. Does that make sense? So I often will start with that number that they give me and be like, okay, like what do I need to know in order to calculate that? Like if I knew the length and width, I'd be able to calculate that if I didn't have it, and sort of work backwards that way. Like, well, how would I get the area if I didn't know it? Because that's going to be what's on the other side of your equation right here. And like, you know, you might start down a road. Like you might start with like, oh, I'm going to make this X. But you would quickly run into a brick wall because we have no way to express the length, like relate the length to that X. Like we just don't have enough information. And that's why I made this guy X, because then I have all the pieces going horizontally and all the pieces going vertically, labeled, even though I don't have numbers for them. And it is, you're right, it's these are challenging because there's like you have to come up with like how to label and things like that, but that's why we practice.
Well, it could bite you because you don't read like how wide and not think that, okay, it's just the frame, how wide is the picture?
Right. Yeah, that part's tricky because the word width can be used in a lot of different ways for sure. But again, like if I had wanted to know the width of the whole frame, like if I'd wanted to know this, I would set this problem up exactly the same way. So the reason that I made X this distance right here isn't because it's what I was looking for. It's because labeling that is the only way for me to then express everything in the picture in terms of a single variable. Right? If I made this one X, then like I really have no idea what I would make this one to relate it to that. So making like this guy X allows me to use it in both dimensions.
The key is getting the variables.
Yes.
Because if you don't, all
Yeah. You guys will have lots of practice. Don't you worry.
she says that with a grin.
Okay, let's do the next one. So the sail on a sailboat is in the shape of a triangle. And there's a bunch of information. I'm going to let you guys do this one. Do you guys know the formula for the area of a triangle?
1/2 base times height.
Yes, it's 1/2 base times height. You can remember it because a triangle is half of a rectangle. So if this is base and height, to get the area of this triangle, you do base times height and then take half of it. So area equals 1/2 times base times height. And our height, I think we all got this far. So then we have this formula here, right? They tell us the area is 54, so we're going to replace area with 54, and then equals 1/2. And then where it says base, we'll replace that with x, because that's what we said the base was. And where it says height, we'll replace that with 3x. So then we're going to have to clear fractions here because we can't factor with fractional coefficients. I mean, we could, but we haven't done that, and it's somewhat tedious because there's a lot more possibilities of fractions you can multiply to make a number than whole numbers. So it's a lot easier if you clear fractions. You can do that now, or you can simplify the right side first and then clear fractions. I kind of see less mistakes, I think, when you simplify first. So we get 3/2 squared on the right side. And then we'll multiply both sides by 2. So 2 times 3/2 x squared. So remember, this is over 1, so those 2's cancel. We get 108 equals 3x squared. So far, so good. And then now we need to get our 0 on one side. So 3x squared minus 108 equals 0. And taking out that GCF really helps here because otherwise the numbers are quite large. I think this is 36. So this factors into x plus 6 times x minus 6. And then we'll set both factors equal to 0. Remember from yesterday, we don't have to set that 3 equal to 0 because it doesn't contain a variable, right? So it's not going to contribute a solution. What's wrong, Mike?
You're just going to 108.
Uh-huh. You know how you can tell if a number is divisible by 3? Anybody know the trick? Yeah, if you add the numbers together and that's divisible by 3, then the number is. So like 1 plus 8 is 9. So that tells me that I can divide 108 by. It's pretty handy. Works for 9 too. If they add up to something divisible by 9, it's divisible by 9. So x equals -6 or +6. Whoa. +6 didn't look very positive. Okay. So we know it's not going to be -6 because it's a length, right? And those always have to be positive. So we get a base. So the base is 6 feet. And the height is 18 feet.
Do it a different way, will I get docked?
It depends on what you mean by a different way.
I did x times 3x over 2 equals 54.
Oh yeah, that's not a different way. You just wrote it differently.
Well, no, because it doesn't go into the factor, you know. Because then you end up with x squared equals 36 and
Oh, so when you solved, what solutions did you get?
6. X equals 6.
So the solution. Other questions on this one? Okay. Let me give you your homework, and we will go